children. So today we are in the first chapter of 10th standard ICSE chemistry, periodic table. Periodic table has been introduced to you in your previous year, where we focused more on the history of the periodic table. We studied about Daubigny's triads, we studied about Newland's octaves, we studied about Mendeleev's periodic table. But all these three principles were rejected. They were rejected because we now have the modern periodic table, which is based on atomic numbers. But these three ideas, these three way of arrangement of atoms or arrangement of elements in the periodic table was on the basis of their atomic masses. So children, you already know now atomic mass is the total mass of the atom, which means the mass of the neutron plus the mass of the protons. But atomic number is only the number of the protons or the number of electrons in a neutral atom. Neutral atom means an atom which has not undergone any exchange of electrons. Is that clear? So coming back to our history. So all these three principles, that is your Daubigny triads and your Newland's law of octaves and Mendeleev's periodic table, were made on the principle of arranging elements based on their atomic masses. But Moseley gave us our modern periodic table, where elements were arranged on the basis of their atomic numbers. So let us understand what is periodicity. Periodicity, period, what does it mean? Period means that after a certain interval of time, something gets repeated. Like, let's look at seasons. Every May we have our extreme summers in India. So can we say periodically we are getting a summer season? Every 1 year we get summer season. Every 7 days we come across a Sunday. Every 7 days Friday also reappears. So this is what we call as periodicity. What is periodicity? The repetition of some characteristics. Now in this case we are talking about periodicity of elements. So repetition of characteristic of elements, some characteristics, not all, some characteristics of elements after a fixed interval of time is called as periodicity. So this is what we understand by periodicity. So based on this periodicity and based even on the history of arrangement of elements, we have come to a certain conclusion, and a lot of studies were done. The studies were mainly on elements, how are the elements oxides formed, how do they react with water. This is how, these were the principles which were applied, because this is how we could decipher their properties. So based on this, where elements are arranged in increasing order of their atomic number. Increasing order of their atomic number means atomic number 1 will be placed in the first position. Atomic number 2 will have a secondary position, so on and so forth. When we arrange the electrons in the increasing order of their atomic number, we see that almost all the time every eighth element have properties which is similar in many ways to the first element. So let us first understand. I will be drawing the first 20 elements orbital structure for you, so that we can understand periodic table very, very clearly. And I would strongly advise that you should know the first 20 elements, the atomic number, their orbital structure and their electronic configuration. This will help you a lot in chemistry. So let us draw the structures. So now we are going to draw our periodic table. That's going to be your modern periodic table, where elements are arranged in the increasing order of their atomic numbers. Now let us look at the vertical columns. How many vertical columns are there in the modern periodic table? There are 18, but I have drawn only 8. What is the reason for that? Because in the modern periodic table, the vertical columns and the horizontal rows which are present, let us first talk about the vertical columns. Vertical columns are separated into two groups. The first group is group A and the second group is group B. Now we are only going to study group A elements, mainly they are called as representative elements, and group B elements are called as transition elements. Transition elements are very common elements. We do study them. Copper, iron, zinc, they are all transition elements. Whereas magnesium, calcium, sodium, potassium and chlorine, they are all representative elements. But in this chapter we are only and only going to study, in fact in your entire till your 10th standard we only and only study group A elements, or we can call them representative elements. Alright, so group A is group 1A, 2A, 3A, 4A, 5A, 6A, 7A, and group 8 is not a part of A. But still we study group 8 because group 8 is inert gases and noble gases that we know about. So we will be studying the 8th group also. And what is the numerical value? 1, 2, then 3 to 12. Group 3 to group 12 are all B group elements. So we are not going to be studying them in this year. Coming to group 13 onwards, 13, 14, 15, 16, 17 are again group A elements, and 18 is group 0. So this is your vertical rows. Now let us come to horizontal columns. Horizontal columns, they also have a name. They are called as periods. So period 1, period 2, period 3, we have till period 7. But for now we will only be concentrating in the first 4 periods. Alright, we have a lot of elements. There are many elements that are discovered which are placed in the modern periodic table. But to understand the arrangement of, especially of group A elements, it is enough that you know the first 20 elements, but you should know the first 20 elements. Nothing lesser than that is going to help you in any way, and there is no reason to rote learn. Let us draw the structure of the first 20 elements inside our periodic table. Alright, so let us look at the first element in the periodic table. Who is the first element whose atomic number is 1? Because they are arranged in increasing order of their atomic numbers. So whose atomic number is 1? Hydrogen. Hydrogen has 1 electron in its outermost shell. So in fact in its only shell, it only has 1 electron. So its first shell is itself its outermost shell. Alright, so hydrogen looks like 1 electron. The electronic configuration is 1. Correct? Alright, so we can see that hydrogen has 1 electron. Coming to helium. Helium has 2 electrons in its outermost shell. So there is one quick exception about hydrogen and helium, where they can be stable by just having 2 electrons in their valence shell, because they have only 1 shell, and according to our 2n square rule, how many electrons can be arranged in the first shell? Only 2. So if an element has only 1 shell, it can be satisfied by just 2 electrons in its outermost orbit, isn't it? But for elements which are larger in size, which has more than 1 orbit, they get satisfied, or they become chemically neutral only when they have a complete octet. That means they have 8 electrons in its outermost shell. Alright, you should remember this. So a completion of octet is when an element reaches its chemical stability. So when an atom is born, let me quickly recap it. When there is an atom which is electrically neutral, that means it has the same number of electrons and protons, but it may or may not have 8 or 2 electrons in its outermost shell. 8 electrons for all elements. Only exceptions are hydrogen and helium. Why? Because they have only 1 shell. Coming back, there is an atom, so it does not have a complete octet. That means its valence shell has less than 8 electrons. So it will either give electrons or take electrons to become chemically stable. So when an atom becomes chemically stable, it loses its electronic stability. That means now there is a difference in charge in the atom. Why is there difference in charge in the atom? Because it has given or taken electrons. So the number of protons and the number of electrons are different. And when they are different, there is going to be a difference in charge. That's why when chemical stability is reached, Usually it comes with electrical instability. But who are the atoms? Who are the elements which are both chemically and electrically stable? They are our inert gases. That's why it's very important to study our inert gases. Now after this quick trivia, let us get back to our helium. Now helium, can I say, by the virtue of duplet state, with that exceptional rule that it has, can I say that it is an inert gas? So we will place it in the 8th group. This is helium. It has a complete duplet. What does it have? It has a complete duplet. So it is also an inert gas. This is our second element whose atomic number is 2. So what is the electronic configuration? 2. Because first shell can have maximum of 2 electrons. Now coming to the third element of the periodic table, whose atomic number is going to be 3. How many electrons are allowed in the first shell? 2. There is one excess electron. Where will the extra electron go? After the first shell is complete, we move on to the second shell. So now we are moving on to period 2. Period 2 will have its first member. The first member of this period is lithium. Lithium has atomic number 3. So let us look at the structure of lithium. Lithium. First shell has 2 electrons. Second shell has 1 electron. So what will be the electronic configuration of lithium? 2, 1. Alright. Next, coming to our fourth element in the periodic table, which is beryllium. Beryllium's atomic number is 4. So what will be the arrangement? 2 in the first shell and the extra 2 in the second shell. What will be the electronic configuration of beryllium? It will be 2, 2. Now the fifth member of our periodic table, we can say it will have 2, 3. Correct? The name is boron. Boron. Boron has atomic number 5. So the first 2 electrons will be accommodated in the first shell, obviously, as usual. And the remaining 3 electrons, because it has 5 electrons, so 2 are gone, 3 are remaining. So those 3 will be arranged in the second shell. 2, 3. This is boron. Atomic the electronic configuration is 2, 3. Then coming to carbon, that's the 6th member of the periodic table. Carbon, it's going to be 2, 4, isn't it? Now can't you figure out 6 electrons in all? 2 are in the first shell, remaining 4 are in the second shell. So carbon 2, 2, 3, 4. So carbon's electronic configuration is 2, 4. Can you see that in this period 2, we are progressing slowly with our valence electron from 1 to 2, 2 to 3, 3 to 4. The electrons in the outermost shell are called as valence electrons. How many valence electrons are possible in the second shell? 8. So up to the point we reach 8, we will remain in this order only. We will only have 2 shells. Then after carbon, we have nitrogen. So nitrogen will have how many electrons in its total electrons? It is 7. So what will be the arrangement? 2, 5. 2, 5. Next, so this will be 2, 5. So the next element in our periodic table is oxygen, a very, very important element. Oxygen has electronic configuration of 2, 6. That means it has 8 electrons. Because this nitrogen had 7 electrons, oxygen has 8 electrons. 2 of them out of 8, 2 are arranged in the first shell. First shell is complete. Rest of the 6 will go in the second shell. So 2, comma oxygen is 2, 6. Coming to the next member of the periodic table. Fluorine. Fluorine has 9 electrons in all. So how will they be arranged? 2, 7. 2, 3, 4, 5, 6, 7. Are you seeing how slowly we are approaching our octet state? Slowly we are seeing that elements now have from 1 electron in the outermost shell to now we have reached 7 electrons in the outermost shell. So this is fluorine. What will be the electronic configuration of fluorine? It will be 2, 7. Alright? Now we come to neon. Neon, can you see now it has to be arranged over here. Why? Because neon, we know it's a noble gas. Noble gas means it has 8 electrons in its outermost shell, or it has its octet naturally completed. So how many electrons in the second shell? In the first shell, 2. How many in the second shell? 8. So total how many electrons? 10 electrons. It is naturally finding its place over here. So looking at neon, 2, neon is 2, 8. Its octet is complete. Now let's move on to the next period. Now we have to move on to the next period. Our second period is full of 8 electrons, 8 elements, sorry. Moving on to our period 3, the first member will be the element which has atomic number 11. Whose atomic number is 11? Sodium. Coming to period 3, the first member of period 3 is sodium. What will be the electronic configuration of sodium? Let us try to find out. It has 11 electrons in all. First shell can only have 2 electrons. How many are we left with now? We are left with 2 gone from 11, 9. Second shell can only have 8 electrons. It cannot accommodate more than 8 electrons. So again 8 are used up. We are left with 1. So what will happen to the last electron? It has to be accommodated in the last shell. You cannot say just adjust because there is 1 electron. That's not possible. Alright. So 2, 8, 1 will be the electronic configuration of sodium. Let us draw it. 3, 4, 5, 6, 7, 8, 2, 8, 1. Next member is magnesium. First shell has 2 electrons. Second shell has 8 electrons, octet complete. And the last shell has only 2 electrons. What will be the configuration? 2, 8, 2. Alright. Sodium, magnesium. Next is aluminium. Aluminium will have 2 electrons in the first shell, 8 electrons in the second shell, and 3 electrons in the valence shell. Why? Because aluminium's atomic number is 13. So 2, 8, 3 is the arrangement. Alright. So this is 2, 8, 3. Coming to the next member. The next member is silicon. Silicon is 14. So 2, 8, 4. So silicon is 2, 8, 4. 1, 2, 3, 4. 2, 8, 4. Next member. So the next member is phosphorus. Phosphorus has atomic number 15. So the electronic configuration will be 2, 8, 5. 2, comma 8, comma 5. 2, comma 8, comma 5. Alright. Then we have sulfur. Sulfur is right under oxygen. Its electronic configuration will be 2, comma 8, comma 6. 2, comma 8, comma 6. 2, comma 8, comma 6. Next, moving on to our 7th group, under fluorine and next to sulfur, we have chlorine. Chlorine's atomic number is 17. So, the electronic configuration will be 2, comma 8, comma 7. Chlorine 2, comma 8, comma 7. 2, 8, 7. And then we have argon. That again, it's found its position naturally in the 8th group, which is our 0 group, or you can call inert gases or noble gases. They are unreactive gases. So after chlorine comes argon. What will be the electronic configuration of argon? 2, comma 8, comma 8. Alright. So argon is 2, comma 8, comma 8. 2, comma 8, comma 8. So we have reached atomic number up to, let us see, 18. We are only going to do the first 20 elements. So let us come to our last period, just last 2 elements remaining, potassium and calcium. Potassium's atomic number is 19, calcium's atomic number is 20. So before we begin, let us just discuss quickly how will they be arranged, how will the electrons be arranged. So when we talk about atomic number 19, so the first element, the first shell will have 2, the second shell will have 8, how many are we left with? 9. So the last shell, the third shell, according to our 2n square rule, the third shell can have how many electrons, total electrons? N is 3 in the third shell, so 2 into 3 square, that is 18 electrons. So we can place those 9 electrons in our last shell, can't we? But there is a condition on this 2n square rule. What is the condition on the 2n square rule? The condition is that the valence shell, whatever may be your valence shell, can never have more than 8 electrons. That is the thing that talks about its stability. Octet state is the state that tells you about stability. So valence shell cannot ever have more than 8 electrons. So what do we do with the last electron? We push it to the next shell, that is the 4th shell. So the first shell of potassium will have 2 electrons. The second shell will have 8 electrons, 4, 5, 6, 7, 8. The third shell will also have 8 electrons. 2, 3, 4, 5, 6, 7, 8. And the last shell will have that extra 1 electron. Again, adjusting is not allowed. Last shell has 1 electron. So what is the configuration of potassium? 2, 8, 8, 1. What will be, what about calcium? Calcium is the last member, not the last member that we will be studying in this chapter, periodic table. Like I told you, since we are not studying the transition elements like iron or cobalt or copper or zinc, that does not mean we are not going to study their reactions either in other chapters. It only means to understand periodic table thoroughly, first 20 elements knowledge is enough. That's all I mean to say by this. Alright. So coming to our last element in what we will be studying or memorizing, that is calcium, or we can say that's the 20th element of the periodic table with atomic number 20. What will be the arrangement? 2 2810 or 2882? It will be 2882. So calcium has 2 electrons in the first shell, 8 in the second shell, 3, 4, 5, 6, 7, 8 in the second shell, 8 again in the third shell, 2, 3, 4, 5, 6, 7, 8, and in its last shell it will have 1 and 2 electrons. So this is your calcium. Calcium's electronic configuration is 2882. So this is how our periodic table can look to us. If we can lift the periodic table that we see in our book, if we can lift out our important elements that we need to study, to understand their periodicity, to understand their characters, to understand their properties and how they are similar to each other or how different they are from each other, this is sufficient for you.